So now here is our review of the assignment that was to implement the tests for the deposit and withdrawal. I have a couple of tests here and I go with you through one after the other. The first test was a very basic test just to see if we can add tokens to our exchange. So I have a token instance and an exchange instance, which I get here in the first part of my test. I call the fixed token supply, the deployed instance, I get the instance, I assign the instance, and I get the exchange and I assign the exchange instance, and then I add the token fixed to my exchange with the token instance address, and I call has token. So I call the exchange has token function, and this returns true if we can find a token, and I assert if this equals 2, and then I see if we have a token called something, and this should assert to false because it shouldn't have this token. Then I was trying another function and I found a current limitation of Truffle or of the test RPC, and here I was actually seeing if I can deposit and withdraw Ether, and I was first checking the balance of my first account, and obviously then I send some Ether to my exchange, and then I withdraw the same Ether from my exchange, and then I check the balance from my first account again, and thought wrongly that the balance before the transaction should be equal to the balance after the withdrawal, but it will not work because when you transfer something, you also have to provide the gas to the miner. And in this case, it will cost something. But the gas we use during the transaction, which we can usually get via the transaction hash. So when we are doing a transaction, for example, deposit Ether and return this, then we get a transaction hash, actually a transaction result. It's not a hash. And this transaction result gives us via the receipt object a cumulative gas used. And we also can get the transaction, the actual transaction via the transaction hash from this transaction result, the gas price. And this multiplied together should be actually the gas used. Now the problem is with Truffle and with test RPC, it just doesn't add up because it will be by a fraction less than the actual gas used. And the reason is that there's some zeros missing behind. So it will show you it used like 4,500 gas. The problem is it's not in Wei, it's in another denomination. So it's like 4,500 something. And from this we cannot, or I was not able to just derive the new balance before and after the withdrawal, depending on the gas amount that we really used. So that function, that test will just not work. It will throw a lot of errors because the assert is not equal the balance before the transaction versus the balance after the transaction. This is this assert here. So I defaulted back to another way of testing the deposit and withdraw Ether. In this case, I get the deposit, the balance before the transaction, the balance after the deposit, and the balance after the withdrawal. So far pretty much the same as before, just that I try to see that the balance after the withdrawal is at least the balance before the transaction minus the gas used times 2, and the gas used times 2 is probably less, so this is at least that one minus the gas times 2. That should work. And then we see if we can be able to deposit tokens. And here I get both instances, the fixed supply token and the exchange instance. And first I approve on the fixed supply token for my exchange address 2000 tokens, that the exchange instance can work in the name of my account with 2000 token. And then I call the exchange deposit token, the fixed token that we added up here with 2000. And then I get the balance, and then I look if I have 2000 tokens in my balance for the account that is calling the exchange. And the last test is we see if we can withdraw the tokens again. So I check the balance, the token in the exchange before the withdrawal, the balance of token in the token contract before the withdrawal, the balance of token in the exchange after the withdrawal, and the balance of token in the token contract after the withdrawal. And of course, if we are going to withdraw, how many tokens are we gonna withdraw? We withdraw all the tokens. So obviously those tokens should be afterwards here in the token contract. And this is what we're gonna assert down here. All of the tokens in our exchange should be 0, and all of the tokens from the exchange should be added to the token contract. So those afterwards should be before plus the tokens from the exchange. I see that I did not write the correct message here, but if the test go through, you will not see this message. Now let's try these tests and see how they react. I've opened here the test RPC again, and I'm in the right directory here, and I type in truffle test, and we will see what's going to happen next. So first the contracts should be compiled and deployed, and then Truffle will go through the contracts and give us all the warnings about unused variables, and also in the fixed supply token contract there's still a throw, which is a warning, but of course obviously we will use all these variables later when we are implementing the logic for the rest of the functions. But at the end our tests will be executed, and you can see that all of our tests run through. So we have first the token tests and then the exchange basic tests. Now if you ever run into any troubles with testing, you can just use a console log. If you want to get the result of, for example, this transaction result, you can type in console log takes result. This helped me a great bit because I could see what is actually in the variables stored inside and then work from there. So this helps with debugging. Obviously, it's not a step-by-step debugger, but if you're used to it from the JavaScript world, from working with your Chrome or Firefox browser, then this will be very, very familiar, just that you have it on the command line. Let's see what's happening. First the basic tests, and then here we are, we have the transaction result object, and it's in the area where the test is executed. I'm gonna remove this again, and you will find all of this code obviously in our repository.